Alright, so what we're going to look at tonight is just a couple more examples of solving trig equations for all angles between 0 and 360. Now, there's a couple specific types that we're going to look at with our solving tonight, and then we'll do a couple more, specifically a couple that are going to be, one for sure that's going to be on your test, and another one that's going to be also on your test. So we're going to go over two types that are going to be on your test that involve some different strategies. But for right now, we're just going to do a couple more to make sure you guys have a good idea or grasp as to what solving is like. So this first one that we're going to look at, 2 sine x plus cosecant x equals 0. So one of the first things that we want to do when we have, or when we're solving, is we want to get the same trig function. So if we don't have the same trig function, then we want to get the same trig function. So how can I change one of these to match the other? So when I think about how can I change one of these? Well, cosecant is 1 over sine. So now I have sine x in my entire equation. So now I want to think, how can I solve or combine my sine x's? So I have a fraction here. So I can, because I'm solving, I can either get a common denominator and add the fractions on the left, or I can multiply the entire equation by the common denominator to get rid of the denominator. So I'm going to go ahead and do that, where I multiply everything in the equation by sine x. So when I multiply it here, I'm going to get 2 sine squared x. Here, it's going to cancel my denominator, leaving me with just 1, and anything times 0 will remain 0. So I'm going to solve for my sine squared x, get it by itself, and I get negative 1/2. Now before we can do our angles, we have to even get rid of the squared. So we have to get just sine x equals to be able to find our angle. So I square root both sides. So I have sine x equals plus or minus the square root of negative 1/2. Well, can we take the square root of a negative? No, it's actually an imaginary number. So this would be something that would give us no solution, meaning there is no angle that will make that equation true. So those same solving techniques or solving things that we had with algebra and solving for x are still going to apply here in terms of you can't square root a negative and get a real number out. Okay, the next one that I wanted to do with you guys, go ahead and put a star next to it or indicate somehow that this is a question that's similar to the test. So this is one that's similar to a test question, and what I mean by that is you're going to have to use this method of solving on one of your test questions. So one of the first things that I notice is that I have a sine squared and a sine x and a constant. So this is going to be factoring, our double bubble. If you're able to factor, because sine squared is just sine x times sine x, if you're able to factor and see that right away, go ahead. If you need to do a u substitution, let u equal sine of x and u squared equals sine squared x. If you do the u substitution, your next step would be 2u squared plus 3u plus 1 equals 0, and then you can factor and then do your substitution at the end. If you don't like u substitution, because I know there's some of you in here that don't, you would skip this step and just go straight to your double bubble, leaving room for your sine x. So 2 sine x times sine x, that'll be my first term. And then I'm going to have 1s for my last term, and I need them to add up to 3. So if this is positive and this is positive, I'll get 2 sine x plus 1 sine x equals 3 sine x. If you were doing u substitution, you would still get here just after you factor and put the sine x's back in, you'll end up at the same place. So just like how we factored before and solved, we're going to take each factor and set it equal to 0. So 2 sine x plus 1 equals 0. And sine x plus 1 equals 0. And we're going to solve each equation. So here I'm going to minus the 1 and divide by 2, so I have sine x equals negative 1/2. And I ask myself, sine being negative means it's down in one of these two quadrants. So which angles give me a sine value of negative 1/2? And I would get 210 degrees for this quadrant and 330 degrees for this quadrant. So those would be 2 of my answers. And then I'll come over to this equation, sine x equals negative 1, and think again, negative is down here. Negative 1 is a quadrantal, so that's going to actually be at 270 degrees. So here we're going to end up with x being 3 different answers because we had that squared in there. So one of the things you're going to have to do is look at some of these like polynomial functions where you factor it and you solve it using the same algebra we did earlier this year, and then it's not until this last solving step that you bring the trig back in. Alright, I want to do one more with you tonight, and then we'll do the last 2 tomorrow in class. And this last one that I want to do with you is what happens when there's something being multiplied inside of your sign with x as opposed to outside. So between the notes on 5-6 and the problems that we did on 5-6 and the ones we've done so far, all of our trig functions have just been sine x or cosine x. There's never been anything inside with x. So this last one is how do we deal with a number or something inside this trig function with x. So I'm going to start it the same way actually. I'm going to treat all of this as just one angle. So think of it as saying theta is 2x, and we're going to come back to theta in a moment. So I'm going to do sine of theta equals negative 1/2. That way it looks like the ones I just did. So now I think on my unit circle, it's negative, so it has to be down here. What angles give me negative 1/2? That was 210 and 330. So theta is 210 and 330. So now what we have to think about is this 2x here. If we go back to our range is supposed to be, all of our answers are supposed to find where x is between 0 and 360. But we don't have x, we have 2x. So if I multiply everything by 2, sorry, I didn't mean to write that there. Multiply everything by 2 in my inequality, I'll get 0, 2x, and 720. What this is doing is it's widening up because of that x on the inside here. It's opening up more options because we're doubling this angle. So when we're looking for our angles, our thetas, we have to consider not only these two, but the coterminal when we add 360 to each one, because our theta is double x. So we would want to look at all of our angles between 0 and 720. And so how we deal with this number on the inside when it's being multiplied is we have to take whatever number is there and multiply it to our domain that we're looking for to get the domain for our doubled value. So when we consider now that we can go all the way up to 720, that means I can consider the coterminal. So there's my 210, but if I do another 360, I'm going to also get 570. So that's also a potential answer, because that's underneath 720. Same thing with 300. If I were to go all the way to 300 and then another 360, I would get 690 as my coterminal. So again, because our angle of sine is being doubled, we have to double our domain, or our possible values of x, so that we can get all of our thetas that could potentially work. So once we have all of our thetas, in this case we have 4, we're now going to go and plug 2x back into theta. So I'm going to put 2x over here. So 2x will equal 210, 330, 570, and 690. But again, we're looking for x, not 2x. So we need to divide everything in half, so that way we can find out what is x. So when we divide 210 in half, we get 105. 330 will give us 165. 570 will give us 285. And 690 will give us 345. And those would be your x values that when you double them give you a sine value of -1/2. So tomorrow what we're going to do is we're going to do another one of these, because this is, I know, a little bit of a different idea when we have something inside. So we're going to do another one like this, and we're also going to do another one similar to number 2 that's also a test type question to finish off our unit. So solving is our last topic of the unit, and we'll start reviewing on Wednesday, with your quiz being at the end of class on Wednesday.